Buildings are silently wasting energy every day. Heat leaks, water and gas issues increase costs and emissions without being noted. Emissions already reached 10 gigatons of carbon dioxide even with huge investments. The problem, we don't detect the issues early and fixing them is expensive, so the gap keeps growing. In 2021, emissions reached 10 gigatons, while energy waste remained unchanged. Traditional innovations are too slow, leaving a major gap in decarbonization. Our market is huge. The total market is over $120 billion with $8 billion as our target segment. We aim to reach 10,000 homes in the first 18 months. Compared to the industry, we achieved up to 40% energy saving and ROI in less than 2 years. That's why this is the first time.
RoboSustain is more than a robot. It is a direct response to the UN Sustainable Development Goals. We are bridging the 9-point decarbonization gap by optimizing building efficiency. Our AI-driven diagnostics actively combat climate change, turning industrial innovation into a sustainable reality for our cities. We are the team behind RoboSustain, an intelligent solution transforming existing buildings into sustainable spaces without a single brick of demolition. Our robot doesn't just detect hidden energy and water leaks, it actively fixes them by installing solar films and advanced insulation automatically. We reduce emissions, slash costs, and extend building lifespan.
The journey begins here, where our MQ5 and MLX90614 sensors continuously scan the environment. Once an anomaly is detected, the Arduino Mega and Sync process the data to classify the hazard type with high precision.
In less than a second, the data is transmitted via Bluetooth to our centralized command center. Users receive immediate visual evidence on the React-based dashboard, bridging the gap between hardware and cloud intelligence.
Beyond detection, the robot takes action. We see the precision of our decision algorithm as it controls the motors to apply sustainable repair materials exactly where energy is being wasted. Finally, a verification scan ensures the building's efficiency has been fully restored.
Welcome to RoboSustain app, a smart dashboard designed to monitor building safety and sustainability in real time. We built this as a progressive web app, meaning it's fast, responsive, and works perfectly on both mobile and desktop. The dashboard tracks live data from 4 sensors. Technically, we used React. We organized the code into components, making the project easy to manage and scale. To handle the data, we created a custom hook. It processes raw signals and moves data in one direction to keep the system stable. With Framer Motion, we added smooth animations for the robot's movement and clear alerts when sensor limits are reached. RoboSustain combines hardware and modern web tech to create a safer, greener environment.
RoboSustain is a completely embedded system, integrating sensors, control units, and actuators. The ultrasonic sensor handles obstacle detection. The ESP32 cam captures images, which our AI converts into thermal visuals, a low-cost innovation replacing expensive thermal cameras. The microphone module detects sounds anomalies, all mounted on the robot chassis, driven by the H-bridge motor drive. Now let's fill it to the pace. The ESP32 is the main controller. 4 DC geared motors power the wheels. Lithium batteries supply the power, held in battery case holders, connected by jumper wires. And the left side, where the sensing happens, solar panels recharge the batteries. The gas sensor detects leakage. RGB LEDs give instant alerts. Micro servo motors rotate the camera and ultrasonic. The raindrop sensor detects water leaks. A power switch controls the robot, and the GPS module streams live location to the dashboard. Using NeoPing and servo libraries, the ESP32 pulls the ultrasonic sensors. Once distance drops below 40 cm, it stops, backs up, sweeps the servo to compare both sides, then turn towards the clearer path.
We tested 3 scenarios: gas leak, water leaks, and cinema analysis, all monitored in real time via ESP32 and BWA dashboard. Results showed rapid detection, gas reading spiked from 120 to 520, moisture dropped from 820 to 300, and temperature ranged from 21 degrees Celsius to 42 degrees Celsius. Distinguish water leaks from electrical faults, and final accuracy 90 to 95% with response time of 2 to 4 seconds.
Welcome to RoboSustain app, a smart dashboard designed to monitor building safety and sustainability in real time. We built this as a progressive web app, meaning it's fast, responsive, and works perfectly on both mobile and desktop. The dashboard tracks live data from 4 sensors.
Hello, we are the team behind RoboSustain, Arwa, Salma, and Rukaya. We have developed an autonomous robotic ecosystem to tackle the building decarbonization gap. Our solution serves facility manager and homeowners. We identified their core pain point. Traditional inspection are expensive, destructive, and slow. To verify a solution, we conducted live testing with users. We didn't just look for approval, we measured performance. Our metric showed a 91 autonomous coverage rate and SUP 2 seconds latency for critical alerts like gas leaks. This evidence proved our system is reliable for real-world safety. We developed our RGB to thermal synthesis using PyTorch. We trained a pixel-to-pixel GAN model to generate thermal maps from standard images. To optimize the model, ensuring the AI recognizes heat patterns even in low light conditions, eliminating the need for $2,000 thermal cameras. For the software, we built a progressive web app using React 19. We choose React for its component-based architecture, making the system scalable. To maintain stability, we engineered custom hooks for real-time data streaming. This ensures that hardware signals flow smoothly to dashboard without unnecessary reranges.
For the software, we built a progressive web app using React. We choose React for its component-based, making the system scalable. To maintain stability, we engineered the custom hooks for real-time data streaming. This ensures that hardware signals flow smoothly to the dashboard without unnecessary re-renders.
On the hardware side, we integrated an Arduino Mega with an ESP32 for cloud sensing. During our debugging phase, we faced significant sensors noise. We solved this by developing a multi-sensor fusion algorithm that cross-reference gas and temperature data to verify anomalies, ensuring our features work accurately in complex environments. Our project went through 3 major iterations. User feedback from V1 led us to add the frame motion for intuitive visual alerts. And in V2, we added a bilingual interface and a sustainability guide to help users take immediate action. RoboSustain slashes building energy waste by 40%, bridging the decarbonization gap with affordable and invasive diagnostic for a safer and greener world. We are scaling into the RoboSustain Hub, an AI-driven marketplace connecting users.
Our business model is sustainable too, combining hardware sales with commissions-based eco-materials marketplace. We don't just find problems, we provide the green solutions. We are RoboSustain, protecting buildings, saving energy, and securing the future. Thank you.